The cursor is working. Okay, cool. So let me start the today's lecture. Today's lecture is about speech, and today we also have our release of the assignment. So after this lecture, we will have a walkthrough of the assignment 3. So hope I can finish it earlier so that you guys have enough time to explain the assignment 3. We actually put a lot of energy, so I hope you guys can enjoy that. Anyway, today's content, I put the 4 items. What is speech, speech applications, speech databases, and speech hierarchy. Probably I will go through at least 3 items, and the 4th maybe hopefully this time or the next Thursday. So the next that I will talk about the most important definition. What is speech? So actually, many people said that it's sound produced by human. Probably it to be true, but in many cases, we actually have a bit more narrow definition, which is the sound produced by human for the communication. That is mostly actually used in our kind of speech processing. But generally, the wider meaning of the speech can be just by humans. That is a kind of the usual definition. And then I will try to ask you guys about the 4 kind of 5 audio. And please answer, this one is speech or not. With what? Is it speech or not? It is speech. Yes, it's very noisy, but still speech. Next. Probably this is not speech, or do you think this is speech? Yeah, probably this is not speech. By the way, all the sound, no, except for the first one, I picked up from the free sound. So this the link is also useful. You guys can get a lot of kind of interesting sound, and actually using it for your research. It's also copyright free, so the quite kind of easy to use. And the third one, is this speech or not? It's actually a bit difficult. So my definition still speech, because laughing and so on actually accelerate our communication, right? So my definition usually they're using it as a speech, and this one is easy. Yeah, even people are typing to do some communication. This is not human voice, so this is not speech, right? And the last one. What do you think? Is it speech or not? So if this is the wide the sense of the sound produced by human, this is speech. But this is not free for the communication, especially singing voice. Well, some people can use singing voice for the communication, like opera and so on. But in general, it is not used for the communication. So again, this the definition is not very clear. But usually people actually regarding the speech and the singing voice are separate. Okay, so this is the definition of the speech. And the next, speech is made by the sound, right? And what is sound? Sound is just a change of the air pressure. And that is captured by microphone. So it's quite physical phenomena. So compared with the various topics we have been studying in multilingual NLP, many of the kind of the problems are more like a syntax semantic, the textual information. But speech is actually quite comes from the the physical phenomena. And actually, this the sound pressure is captured by microphone and they converted as this the one-dimensional waveform. And usually in this lecture, I use this one-dimensional waveform as an input to our problem in speech the processing. But it's actually not one-dimensional. Like for example, human ear is a very good example. We actually at least have a two-dimensional the waveforms. And many of the smart speakers, including this one or the Alexa and so on, they also have the more microphones. But in general, each of the kind of channel of the signal is the one the dimensional time domain waveform. And since this is a waveform, so this is governed by the well-known physical properties. Not sure how many people remember this kind of properties: attenuation, diffraction, the diffraction, superposition, and so on. So actually, these properties are quite making speech signal to be rich information. And due to this kind of property, especially superposition and reflection is a kind of very important the property to include a lot of the information inside the waveform. This becomes the rich information in the speech. So first, second question actually. The second question to you guys is, what kind of information does speech sound contain? Of course, I will talk about the speech recognition. So this means that the speech includes the linguistic contents, transcription, and so on, right? And the speech also has the speaker characteristics. Is there any other information that speech can deliver? Can someone tell me?
Non-phonemic signals like emphasis, pause, and so on.
Yes, exactly. Any others?
Emotion.
Emotion, yes, good. Are there any other examples? Actually, quite a lot, by the way. For example, one of them, Graham, yes.
You can tell if somebody's sick.
Yes.
Like if they have a cold,
yes.
Or if they talk too much the previous night.
Yes.
Physical.
Exactly. Or even the other faculties here also try to kind of detect the person is COVID or not from the voice signal. So voice can also include the health information. Voice also, the speech also include a lot of other information. For example, we can speech information even include the location. You guys can identify at least which direction speech comes, right? This is not purely speech, but it's with a kind of multiple the signal of the speech. We can identify which location speech comes from. Speech also includes the reverberation. So from the reverberation, we can even approximately say the room size and so on. Is there any other information? Maybe a lot. I can come up with the many of them. And actually, this the information is the correspond to various the speech application. So now move to the speech applications. So the speech applications depend on the problem, but actually the many of the problem is to try to capture what the information is delivered from speech. Speech recognition is a good example, right? And the speech emotion recognition try to capture the emotion. And of course, we also have the opposite problem. Given the text to generate the speech synthesis. This is also the speech processing research topics. And we actually have tons of the problem in speech. Speaker recognition, as I mentioned, speech delivered the speaker characteristics, right? So that from the speech signal, we can actually identify who is speaking. Oh, I forgot to mention about it. This is actually very important for the multilingual NLP, language recognition. From speech sound, we can also identify the language. And there are a lot of the speech, the problem. By the way, these topics I extracted from the topics in the interspeech, which is one of the biggest speech conference. And the deadline is next month, right? 1 month right after, right after this, 1 month right after this today. So if people here are thinking about doing something for speech, interspeech is a good target. But I think if we link it to the term project here, maybe it's a bit too late. Okay, so we have a tons of the speech application. And by the way, among them, the next question, among them, what is the most widely used technique? There's, some, how to say, the definition, what is mostly used. But I think everyone can agree if I mention the answer. So can someone say what is the, yes, Kati?
Speech coding.
Yes, I think you know that.
Next slide.
Yes, okay. Do not check the next slide. Because people usually cannot answer. Okay. So yeah, speech recognition, probably in terms of the number of the researchers, the biggest one is speech recognition, and the next biggest would be, second biggest would be speech synthesis, and the others are kind of following. And the speech coding is actually a bit the already solid technique. So there's not so much research in this area, but actually speech coding is the most used technique. And actually, the speech coding is unique compared with all others. All others are trying to, how to say, some given input to extract some information or enrich some information by generating that and so on. The speech coding is try to keep the original information, but try to kind of compress the information as much as possible. And actually, this was one of the first, the most active study in the early the speech the processing research. Since at that time, compression is quite important. And also compression actually tells us what is speech, what information is delivered is quite important if we consider the speech coding and so on. So that's why people starting to work on the speech coding. And then we move to various the applications, and now many of them are actually getting quite matured, I would say. And one of the techniques I would like to mention is speech recognition. And that can be covered in Thursday. And after the break, I will also revisit the ASR part again. So using the 2 lectures to explain about speech recognition. But the speech recognition is one of the very complicated system. If you guys really want to understand speech recognition, it may take 1 semester. So then please take the speech recognition and the understanding in the next fall semester, if you really want to know that. So next, the second biggest application is speech synthesis. And the speech synthesis is also the given the text to generating the waveform, and have a wide applications. And I think this is the possibly the second biggest applications than speech recognition, I believe, because everyone now, heard about the TTS synthesize the voice, right? So in terms of the application, this also has a big success. And as everyone here may know, you guys are lucky. So Professor Alan Black, he is the pioneer of the text-to-speech, and he will have a lecture about TTS. I'm also very looking forward to that. Okay, so there are a couple of others, and I try to pick up not everything, but some of them that are interesting or are important. The next one that may be very related to this course is speech translation. So the directly converting the source speech to the target text. So in this example, Japanese speech is translated to English text. How to do it? One simple approach is to combine automatic speech recognition first, and then machine translation. And this is probably the most kind of widely used way. And I think this way should be also considered. But the two systems, combining two systems are a bit complicated. And also, if we have an error in the ASR side, it cannot be well recovered in the second machine translation side. So people also are starting to directly using an end-to-end neural network to solve the Japanese source speech, like a Japanese speech, to English text directly without outputting Japanese text and so on. And this approach is quite important if some languages don't have their own scripts, but they often kind of have a kind of the translation to their colonial languages and so on. There are a lot of such kind of database actually, and then this speech to text direct information is also quite important in these cases. And this is to the speech to still text. But if we try to use it for the interface to communicate to the foreign, people in the foreign countries seamlessly, we also want to develop the source speech-to-speech translation. In this case, source speech is English, and it is converted to the target speech. And this is also started to be very popular, not only as a research, but also as a product. And many of the systems are currently using the combination of the speech recognition first, machine translation in the middle, and then other TTS, text to speech. But there are a lot of kind of recent emergent techniques based on the end-to-end single neural network to even the model this kind of a very complicated pipeline based on a single architecture. And I think this is one of the ultimate goals of multilingual NLP, right? If we have a perfect speech-to-speech translation systems, probably we can solve many of the problems discussed in this work. But this problem is quite difficult, and a lot of studies are going on now. So these are related to multilingual NLP, and I will also introduce some of the other speech applications which would be very related to our problems. So I just kind of combine the speaker recognition, language recognition, speech emotion recognition, audio event classification and detection. So actually, speech information has a lot of profiling information. So as I mentioned, the speech recognition is one of the example. This means the linguistic information, right? And with speech also has the speaker, gender, age information as well. Age is not very correct, but we can still actually predict some range of the age based on speech. And the language, we can also get the information from speech. Emotion that we have discussed, that is also extracted from speech. And this is not completely speech information, but let's say environment is important for us to understand our the communication scene and so on, right? And then audio event. So when I am speaking, the fan noises, walking on somewhere, right? This kind of information, all the kind of informations are included in speech. So superposition property is quite nice in terms of packing many of the information into the one sound waveform. So this the property is very good, but it's getting a bit more difficult, not difficult, but challenging problem, privacy in speech. Since speech has a lot of information, so the working on speech means we potentially touch a lot of information of that other person. So the people are also seriously thinking about the privacy, and on-device approach becomes quite important due to this. I'm checking how many slides I have to finish. Maybe this is very cool, so I can also introduce this one. So as I mentioned, the superposition property is very cool in terms of the getting various information in the environment, right? But this information is not always useful. Actually, many cases, we just want to focus on target speaker, right? So then the speech enhancement, speech separation techniques are also very important. It's not very related to this the lecture, but I will just explain about it because many people actually often ask me, my answer doesn't work, and most of the cases it comes from noise. So I just want to emphasize that, and there are ways to deal with that. And there are several types of the noise we have to deal with. The first is a kind of how to say the environmental sound that adding to our the usual sound. You guys, I guess, can still recognize it, right? Computer actually cannot at all. Probably you guys can do better than computer. So to solve this problem, we also have the denoising techniques. This is actually after the denoising. Sounds better, right? This is actually very good for computer. And the next, reverberation is also another very the annoying issue. Again, for you guys, it is not so difficult to recognize. But for computer, this reverberation, echo, is quite harmful. So there's a technique to suppress the reverberation called the reverberation technique. If you guys using the headset microphone, you guys can even clearly find that the echo is removed. Since this room is a bit large, so actually echo is further convolved in the reverberated speech, but I believe still people can understand it. Next one is the separation. I think I prepared a very cool demonstration by oh yes, I prepared this demonstration. This is actually he's my former colleague when I was working at the Mitsubishi Electric Research Laboratory, Jonathan Lulu, and he was planning to come here this Friday, but it was canceled. So it is unfortunate, but instead I just play his cool demonstration. You can see that the mixed speech is completely separated, right? So this is one of the pioneering work of using deep learning for speech separation in the first time. And this is already very clearly separated, right? But now the technology becomes matured, and this kind of a simple speech separation problem is almost solved. However, we have a lot of other difficult separation problems. Okay, so I think these are more like the applications that I want to cover. There are a lot of other applications. If I have time, I can also want to introduce some of them, like a spoken dialogue systems and so on, but I just skip them due to the time limitation. Okay, so next, I will talk about speech databases. To work on this kind of cool speech problems, we have to have a database. And the speech, as I mentioned, has variations, a lot of variations, right? And there are many axes, but mostly we classify the speech database with the speaking styles and the environment and so on. But I will just talk about the speaking styles for now. So one style is red speech, and the other is spontaneous or non-red speech. And I will explain how it is different. Maybe I can play some of them. So this one, first one, Wall Street Journal. This is one of the most famous speech recognition corpus. So if you guys have some cool idea for the speech recognition techniques, And the showing the kind of the improvement in this Wall Street Journal, you guys can write a paper. So it is a bit. So the gain is small, but it is a so-called red speech. And why it is called Wall Street Journal? People are reading the Wall Street Journal sentence, so that this corpus is named Wall Street Journal. Switchboard. This is an example of spontaneous speech. I think it is obvious that the second one is more difficult, right? But the second one is more the natural conversation. And the third one, this is the corpus called lively speech. And I mentioned that the Wall Street Journal is one of the most famous speech corpora. But now this lively speech is the most famous, the most frequently used the corpus. Why it is used so popularly? This is simply because the license is quite flexible. Wall Street Journal has a kind of a little bit limited license, while lively speech doesn't have so much restriction for the license. And also the amount of data is also quite large, 1,000 hours. So that's the reason that the people are using the lively speech so often. Okay, I will try to explain a bit more about what is red speech. I kind of mentioned already about some of them. So red speech is usually collected as follows. First, we have some sentence showing in the prompt. And then we can just read this prompt, which are corresponding to, we get the pair data of the prompt and the corresponding speech data. That's it, right? It's very easy. I believe I prepared this. How many people knows this? The web page, this kind of activity, Common Voice. This is a widely the used the speech the data collection scheme led by the Mozilla, and this actually has tons of the multilingual speech resources now. So if you guys want to get some speech data, the one of the first place you will check is this Common Voice. And this Common Voice, the collection is based on the red speech prompt. Difficult. For example, if you click this one, not sure it's working, but she has also served as chair of the board of Bone Health New Zealand.
Need to allow like
Oh yes. She has also served as chair of the board of Bone Health New Zealand. and the next prompt is comes, and I will speak that. It is very cool system, right? And then we can actually collect a lot of languages. And again, this supports many languages now. I was super happy when they started to support Japanese, and I spent half day just speaking Japanese. So probably many of my voices are used in this database. However, be careful. People sometimes don't speak correctly. How to then deal with that? They actually not only recording. They actually have a. Oh, sorry. Maybe I can reload it. This is a bit difficult because I have to. They also have another action, listen. This actually confirms whether the recorded speech is correct or not. And I haven't tried a listen part. I just only speaking in my Japanese. So not sure someone correctly they recognize my Japanese and registered it as the useful corpus or not. So this is the red speech. So again, this is easy to correct, but I have a lot of experience that the people don't speak correctly. So we actually need to check whether they are speaking correctly. And also easy to anonymize compared with the spontaneous speech, because it is prepared sentence. It is not connected with the speaker's identity. So if the speaker is completely anonymized, that we don't care about it. But the problem is that red speech is not the real conversation. So this is a very good start to build a speech recognition system. But if I put it in this system in the conversational scenario, it will not work so well. So instead, we also use the spontaneous speech. And this one is very tough. It's actually hard to transcribe actual recording. Again, I prepared an example. By the way, how many people use this tool, Audacity? Do you know that Audacity is developed here, CMU? Yeah, again, you guys are very lucky that CMU can provide any of the tools for the speech and the NLP research. And I think I prepared wait a moment, the way to transcribe the speech, the switchboard speech. I think, okay. Oh, I actually put the latest slide. Wait a moment. So my computer is not working now. Okay, now it's working. So if I have more skills to switch a screen and so on, I can do some demonstration in front of you, but it's very difficult to do it by checking the back monitor and this monitor. So instead, I will just play the audio, play the video of how to transcribe the spontaneous speech. Check the segment part manually. Then type OK. Check the segment. Okay. Just to transcribe this, I don't know, 5 seconds of speech, it takes a very long time compared with the let speech, right? So this is quite time consuming, and it is quite expensive to collect such kind of data. Like for example, this switchboard, this is a switchboard corpus, which is one of the another famous speech recognition corpus, but this is spontaneous speech. And the when in the previous my lecture, I actually had a homework to the student to transcribe 2 minutes of the switchboard conversation. I think, yeah, the 30 minutes is actually shorter side. Most of the people takes 1 hour. Or this is one of the most, how to say, biggest complaint of my homework actually, since it is really, really hard. Of course, transcribers are very professional, so they can finish it a little bit earlier. But still, the spontaneous speech, the recognition, no transcription, is very, very difficult. I think I need to finish it in 5 minutes or so. So this is the just speech is very fluent, but the real situation is the more difficult. Like for example, in the real situation, the meeting scenario or conversation scenario, this is mostly we use for the speech, right? And then the situation is even more difficult. Like I mentioned last in the speech enhancement demonstration, we have a background noise, we have our interference speaker, and we have a reverberation, and so on. But this is a kind of again our usual the everyday conversation scenes, right? And we can easily recognize this kind of sound speech. While the Alexa and so on, I guess you guys have the experience. Just putting it to the and then we started to conversate it. They actually cannot recognize well. They even don't know the which the person they recognize and so on. It's very difficult problem. But again, human can do it easily. And I am actually working on this area a lot. So not only for the spontaneous speech, but also in the kind of real everyday conversation scenario. And the project is called the Chime project. And this is we actually collected such kind of a very the adverse the environment, collected speech in the very adverse environment, and then also the organizing the challenge, making a baseline and so on. I can play some of them. So compared with the previous conversation, it has a lot of overlap, by the way, also noise and so on. But again, this is a natural conversation. It makes the speech very difficult. So I think, yeah, I will finish it in a minute. So there are, again, a lot of types of the speech, and many researchers, many the institutes actually collecting the data for the research and the development for the community. And we can actually access to such data easily with some of the repository. One of the most famous one is LDC, Linguistic Data Consortium, where you can actually get famous ASR benchmarks like a TIMIT, Wall Street Journal, Switchboard that I mentioned before. However, as I mentioned, this has some kind of restriction for the use. We have to pay to get this kind of data. But again, fortunately, CMU is a member, so everyone can actually get LDC data freely. So for this part, you guys would not have any kind of issue, I believe. And not only for the LDC, there are a lot of other institute, government institute, or some the university and so on, hosting a lot of the speech corpora. So you guys can actually get such kind of the speech data through this kind of repository. And the second, the bullet items are getting the more popular now. The box forge, open SLR, common voice, Denoder. And the common voices that I mentioned before. And these data usually have a less restricted license, mostly Creative Commons, so that we may not go through the LDC and can easily get the data and even redistribute the data and so on. So due to this reason, recently many people actually starting to use this data in the box forge or common voice and so on. Especially people working on the like for example machine learning and not in the NLP or speech. Some people may not have an access to the LDC, and then people using this kind of a repository to get the data. So these are also important resources. By the way, these are important resources for the assignment 3 as well. So that's why I kind of spent some time for the explanation. And the last one is the audiobooks or public recording with captions. YouTube actually, the 10% of the YouTube videos has a caption set by the uploader. So we can use speech and corresponding captions. And the same for the podcast, for TED Talk and so on. Generally, they have some captions. So that we can actually use such kind of data and so on. But for this data, maybe you guys also check the license. Sometimes it's very strict, sometimes not. But for most of the kind of research purpose in the academic institute, it shouldn't be no problem. But the more difficult part is that this recording is like, for example, just 1 hour and a half of the long recording and corresponding very long the caption. So it is just too long for us to use it. So we need to correctly segment it. And also this caption is very noisy. So it is not easy to use this kind of caption. Another very important difficulty is that this kind of data is updated frequently. So they're often deleted. So we cannot actually assure the reproducibility if we're using this one. And one of the famous the database is actually CMU's wilderness database. Again, the Professor Alan Black collected, and it actually has 700 languages. Wow, that is very cool. But it is also has some issues written here, like a bit noisy, or API. If API is changed, it is not easy to get the data and so on. But in general, this is also very good source. And the very last, this is important for the assignment. For speech recognition, we often use hour as a unit. So please remember, I even thought that this is a common the sense for everyone, and they use it without caring about your prior the knowledge. So I also want to actually define it. We often use it the hour, and let's say more than 1,000 hours, we can make a commercial system, but it requires a lot of computational cost. 100 hours. Speech recognition started to be working. So we can do the research and so on. Less than 100 hours, it is categorized as a low resource language in speech recognition. So please understand this range of the data if you try to tackle speech recognition. And then I would like to pass it to the assignment 3. But maybe I can accept one or two quick questions. Any questions? Yes, Karthik.
Like annotating the spontaneous speech, like could you first pass it into a voice activity detection?
Yeah.
Segment it and then annotate it?
Yes, usually there are such kind of assisted tool, lot of assisted tool. Even we use a pre-speech recognition and then do it. But the voice activity detection is super important. So we usually have such kind of the rough voice activity detection. But voice activity detection is not working in the noisy environment so much. So anyway, most of the cases, the human segmentation is also quite important. And the question, yes.
Yeah, I have a question about the speaker separation. Does that get harder if people have like very similar frequencies when they're talking?
Definitely, we have such kind of other issues. Since we try to capture more like a similar prosody information, and then like for example, the same gender, and then speech separation performance is bit worse. And it's working very well in the male, female, and so on. So it's definitely this kind of thing exists, but still the current technology almost perfectly separate. In this very ideal situation, we almost perfectly separate the speech, even in the same gender. But it's a good question. Okay, so maybe that's it, and I want to pass it to this, the Shankai and Patrick.